So today we're going to cover Chapter 3, Section 2. Today we're going to be using parallel lines and transversals. So we have 4 new theorems. They're actually, none of these are postulates. In our old textbook, the first one was actually a postulate, but these are all theorems. And all 4 of these have the same beginning. And they all have this same if statement. So if parallel lines are cut by a transversal, then corresponding angles are congruent. And this is called the corresponding angles theorem. The next theorem is going to be called the alternate interior angles theorem. And again, it's got the same beginning. So you would take this if statement and put it in front. If parallel lines are cut by a transversal, then alternate interior angles are congruent. And then the third one has the same beginning. If parallel lines are cut by a transversal, then alternate exterior angles are congruent. And then finally, the fourth one, if parallel lines are cut by a transversal, then consecutive interior angles are supplementary. This is the only one that doesn't have those special angle pairs congruent. The consecutive interior angles are going to be supplements, and that's called the consecutive interior angles theorem. Remember, in other textbooks, they're also called same side interior, but our book uses the term consecutive interior. So this is the only one where the angles are not congruent, they're supplements. We will be using these theorems in our proofs that we're going to be writing on this Chapter 3 test. Tomorrow, we're going to see the converse of all of these theorems. When you use these reasons, these theorems as a reason in your proof, you need to specify that they're theorems, because tomorrow they'll be converses. And if you don't specify, you get it wrong. Okay, so for our first example, they actually want us to find the measure of these 8 angles. Now, my picture shifted a little, so let me go ahead and clarify what we're seeing here. Okay, so here we have our figure, and they're asking us to find the measure of these 8 angles. Sometimes it's easier to fill in the picture versus to try to answer the questions in order. So I'm just going to focus on the diagram first, and then I'll go back and fill in the answers. So if I sort of zoom in here, I've actually got a set of parallel lines here. Notice these huge arrows that they put on here. So this line is parallel to this one. And I've actually got 2 transversals. My first transversal is right here. And I'm going to use this transversal to figure out the missing angle 8. Now notice it's got a little box around it, indicating that it's going to be a right angle, because this angle that's up here is 90 degrees. And notice that this angle is corresponding to this angle. So angle 8 will also be 90 degrees. Now, when I did this, I ignored this half of the picture. All I had to worry about was that blue transversal. Now, to answer all the other questions, I'm going to ignore this side of it and only focus on the transversal that's over here. So let me make that transversal in purple. So now I'm focusing on this transversal, which is going to be intersecting the 2 red parallel lines. Now, when I go to answer the questions for 5, 6, and 7 down here, I don't even really need to use any of my information from Chapter 3. I can use all my information from Chapters 1 and 2, because I can see that angle 6 along with the 130, these are a pair of vertical angles. So angle 6 is going to be 130. And then if you look at angle 5 and 6 together, or even 6 and 7, these are a linear pair. So to figure out the measure of angle 5 or 6, 5 or 7, all I have to do is 180 minus 130, and that missing angle of 5 is going to be 50 degrees. And 7 is vertical to 5, or again, you can think of it as being a linear pair with 6, or a linear pair with the 130. Now is where we need to tie in our chapter 3 knowledge. So again, if I box this, I could use my corresponding angles, or I could just use alternate interior and alternate exterior. It really doesn't matter. You could even use your same side interior. So what do you know about angles to, what would be an alternate exterior angle to 6? What's alternate exterior to 6? Gabrielle? Good. Angle 2 is alternate exterior to 6, and we just learned that alternate exterior angles are congruent. What would be an alternate interior angle to 5? Alternate interior to 5. 4. Good, Fabiana. So since I know that alternate interior angles are congruent, angle 4 would be 50. Now really, I don't need to bring in any of my other prior knowledge, any of my chapter 3 knowledge. I can just use vertical angles now. But again, we can still use all of that other information that we learned about. Notice 4 and the 130, these are supplements. 50 plus 130 is 180. But if I fill in the rest of these, 3 is vertical to 2, and 1 is vertical to 4. And notice in my picture, the only numbers I'm seeing here is 130 and 50. And again, that's what you're going to see when you have the parallel lines cut by a single transversal, that the same two numbers are going to be repeating throughout the picture. So 1 and 7 would be alternate exterior, 2 and 6 like we saw. Then the alternate interior would be the 3 with the 130, or the 5 and the 4. And then the corresponding could be 1 and 5, or 3 and 6, or 2 and the 130, or 4 and 7. And then you also have the consecutive interior, which will be the supplements, 3 and 5 together, and then the 4 and the 130. So we're using our knowledge of the special pairs and vertical and linear pair. So now that I filled in my whole picture, now I can go back and answer all the questions. So angle 1 we saw was 50. We also saw that angle 5 was 50. So was 7. Angle 2, let's go back. Angle 3 is 130. Angle 2 is 130. Angle 4 was 50. Angle 6 was 130. And angle 8 was the 90. So sometimes it's easier to fill in the picture first, especially if they're asking you to find multiple angles in the same picture. For this picture, I know the arrows on these lines right here, they're easy to see. They're nice and large. These are parallel lines, but then if you notice, I got little arrows right here indicating these are parallel as well. Now, when I go to answer the questions here for X, Y, and Z, I'm going to be using different parallel lines for each one of the variables. So for my first variable, X, I'm going to pretend like this line isn't here. And I'm just going to work with the two red parallel lines, and I'm going to treat that purple as if it's my transversal. So what type of angle is X and the 110? What do we know about the measures of consecutive interior angles? Are they congruent or supplements? Beautiful, they're supplements. So what I can do here, and this is how you can do your homework, is you can show if they ask you to write an algebraic equation, you're going to do x plus 110 equals 180. But essentially, if it doesn't ask you to write an algebraic equation, all you're really doing is subtracting 180 minus 110, and x equals 70 degrees. Now, I'm going to erase some of this, some of my scribble, because I need to see where y is over here. So now, for y, I'm going to go ahead and use some different parallel lines. Let me erase and start over. I'll put the 70 back because I need that 70. All right, so this is 70. So now what I'm going to use is I'm going to use these two lines that are parallel. And then I'm going to use this line as the transversal. What kind of angles do I have with my x and my 2y? What kind of angles are those? Notice they're both in the same area of the box. So these would be, Gabrielle, corresponding angles. What do we know about corresponding angles? They're congruent. Good. Okay, so what I can do is I already found the value of x, so I'm going to set 2y equal to 70. I'm going to divide by 2, and y equals 35. Because this angle here is 70 degrees. Because they're corresponding angles that are congruent. They're both in this upper corner of the box. Or you can think of them being on the same side of that red transversal, but one is on the inside and one is in the exterior portion. Now we got to figure out 2z. And actually I could use those same two parallel green lines, but instead I'm going to bring in another transversal here. And let's do this one in purple. And again, I could box around it. What kind of angles are the 110 and the 2z? Corresponding again. Good. Okay, what do we know about corresponding angles again? They're congruent. So in order to find z, I'm going to solve 2z equals 110 divided by 2, and z equals 55 degrees. Now, you could have also, and let me just redraw this here, I could have also found the value of z by using the other transversal. So I had 2z here, 110, the x, and the 2y. You could have also done this. You could have used these parallel lines and this transversal, and then these two angles here, the 2y and the 2z, that's not a 22, it's a z. These would have been consecutive interior. Well, we already knew 2y, this angle was 70. So the other way to find z, you could have done 2z plus 70 equals 180. And then subtract 2z equals 110, divide, and I still get z equals 55. This would have been doing it as consecutive interior. The first way I did it with the orange, that was corresponding. So sometimes when you have multiple parallel lines and multiple transversals, sometimes you can use any of the special angle pairs. Okay, so now we have a real world example, and it says when sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. So for violet light, we're going to see that the measure of angle 2 is 40 degrees. They want us to find the measure of angle 1. And they want us to know, how can we figure out that measure of angle 1? So let me go ahead and go over the lines a little bit better because they're kind of faint here. So here's the yellow line. And notice it's got an arrow on here indicating it's parallel to this one. And then we also have this purple line going here. And this is my transversal. So here is angle 2. And here is angle 1. What kind of angles are 1 and 2? Beautiful. These are alternate interior angles. And what do we know about alternate interior angles? That they're congruent. So if the measure of angle 2 is 40, then the measure of angle 1 is 40. So these will be alternate interior angles that are pictured, and you need to know that alternate interior angles are congruent when the two lines are parallel. This last slide is actually wanting us to prove the alternate interior angles theorem. So I can't use this as a reason in my proof. But since I'm going to prove it right now, if I asked you to do this proof, you can do it in 2 steps after I do it the long way first. Again, I'm not going to ask you to prove a theorem on a test. But this is just helping with your logical reasoning right now. So statement and reason columns. Remember, never ever leave off this given. P, parallel to Q. Remember those 2 lines going down are the indication that these 2 lines are parallel, and this is given. Now, technically, because I know that theorem, my next statement could be that 1 is congruent to 2, and the reason would be alternate interior angles theorem. However, I'm proving that, so I can't use it yet. But what I'm going to look to see is, what else do I have in here that has been previously proven? I can see that I have some congruent angles here between 1 and 3, and these are corresponding angles. So I can now state that angle 1 is congruent to angle 3, and my reason is the corresponding angles theorem. And I'm going to abbreviate theorem as THM. Next, I'm going to look for another congruent angle pair. And notice I could also say that 2 is congruent to 3 because they're vertical. So angle 3 is congruent to angle 2 because of my vertical angles congruence theorem. Because we use this so much, this is the acronym I use, VAT. Otherwise, you're going to write out the words, vertical angles congruence theorem. And now, since I have both 1 and 2 congruent to the same angle 3, I can use my transitive property, and I can state that angle 1 is congruent to angle 2, and the reason is transitive. And you could have also said substitution. Generally, whenever it's transitive, you can say substitution. But not always when it's substitution can you say transitive. So you have to be careful. So this is how you prove the alternate interior angles theorem. However, if the question would have just been this, we could have done it in 2 steps. Now that we've done this proof, put our statement column and our reasons, and again, state the given, P parallel to Q, given, and then step 2 is just angle 1 congruent to angle 2, and the reason would be the alternate interior angles theorem. But since they asked me to prove that theorem, I couldn't use it as a reason. So, yeah, so VAT is my acronym for vertical angles congruence theorem. I just try to abbreviate it as quick as possible. Instead of saying VA, CT, it's just VAT. Okay, so no work for this homework on numbers 1, 2, and 11. The rest of the problems need work. Even if it's something as simple as doing 180 minus the angle that's there. So no work for these. I want you to redraw the picture or screenshot the picture when you're working out the problem.